Hello, everybody, and welcome back. We are still talking about rationals. I hope you're enjoying rational functions, but back in Unit 1, I promised we would continue talking about transformations. So this is a perfect opportunity for us to think back on our knowledge of transformations and apply them here in this unit to rational functions. So I'm going to start by graphing our most basic rational curve. We talked about 1 over x as our kind of base graph for a rational function. And today we also know a lot about asymptote behavior. So if I put in x equals 0 as a vertical asymptote, you guys are going to say, yep, that's correct. Similarly, for this function, take your time to think through it, but the horizontal asymptote will occur at y equals 0. So I'm going to place that in there as well. So asymptotes should feel good. If they don't, feel free to just kind of look back on our last couple days. We talked through vertical asymptotes one day and then horizontal the next. So I want to test our knowledge of transformations, reaching all the way back to Unit 1. And I want to see if you guys can help me out with moving the space graph around. So how do we move the graph, let's say up by 2 units? I'll give you a specific vertical shift, and I'd like you to give me the equation of the function that would generate such a graph, just using your prior knowledge. So even if rationals aren't super comfortable yet, you guys know from the past how to bump a graph up by 2. What do we do to bump a graph up by 2? And after thinking for a minute, maybe kind of flipping back to some notes from Unit 1, feel free to pause and answer this before I do. That's always much more rewarding. But I think you'll agree we just need to tag 2 on to the function, not to the input, but to basically the end of the function. So I could actually do that in Desmos really readily by just saying add 2 to the function. You guys may prefer if I make it a new function, g of x, where I just type in 1 over x plus 2. Maybe that will feel a little bit more intuitive. What I just typed before was the same thing, but we basically need to tag on that plus 2 separate from the input, and that will cause a vertical shift. So the graph in orange is now the blue graph shifted up by 2 units. And it may be a little bit hard to tell that's what happened. So let me go ahead and lock in on a point from the base graph. So I'm looking at 1, 1 on the base graph. I'll label it there. And then just to demonstrate that we did in fact move our graph up by 2, 1, 1 should be transformed to 1, 3, right? That would involve the vertical shift. So for the same input, the output should have been bumped up by 2 units. And so you can see a little bit more clearly now maybe that if we lock onto a particular point, it does in fact move up by 2 units from the blue base graph to the new orange graph. So if you guys can move a graph up by 2 units, I know that means you can move it up by any amount of units. I know you'd be comfortable moving it down by any amount of units. So for those of you enjoying the Desmos experience, change this 2 to a k, add k as a slider, let k play, and you can kind of look at an infinite number of vertical transformations. So I know I'm going through Desmos a little quicker today than I did in the past. You guys are gaining some comfort with it, and I hope you find it to be a really useful tool. So I'll just let that play for a minute because it's kind of enjoyable. All right, so feel free to, again, build this Desmos sheet for yourself, be in the driver's seat, highly encouraged. But because I'm going to share this Desmos sheet with you, I'll change it back to a shift up by 2, and we'll let that be good. So I'll go ahead and save and share this exact sheet with you. Okay, let's do something else though. Let us ask ourselves another question. You guys know what I need to ask. How do we move the graph? Let's say right by 3 units this time. So I did our vertical shift first because I think vertical shifting is a tad more intuitive than the horizontal shifting. So what will we do to the original base graph, this f of x equals 1 over x, to move the graph to the right by 3? So let's just recap. We know left and right motion is kind of the opposite sign of what you might think. So to move a graph to the left, you're actually going to add that number. To move a graph to the right, you're actually going to subtract that number. And the place where we add or subtract it here is actually going to be to the input itself, to what in future classes or even later in this class we'll start calling the argument. So I'll call our new transformation h of x just so it's different from the f and g that I've already used. So if I want to move my graph right by 3, I take my input, which I'm highlighting here as just x, and I need to subtract 3 from it. And let me change the color. I think we did good work. I'll turn off a couple other points real quick. How does that look? Does it look like we took the base graph shown in blue and transformed it to the purple graph? Moved it right by 3 units? It should look good, right? But let's do that same kind of test that we did with the vertical shifting. Let's just make sure this 0.11, if we wanted to move the graph to the right by 3 units, that means the x value should jump from 1 to 4, and the y value should not change. So 4, 1, let's make sure that falls on our new purple graph. You guys are probably noticing it before me. It looks good, right? So 4, 1 is just demonstrating a kind of point-by-point transformation to verify that the whole graph did in fact get transformed in the way that we wanted. So that's kind of fun, right? And again, in Desmos, I chose a specific transformation. I chose to move right by 3. You guys could just as readily take that 3 that I just put in, tag on like an H. I know we used H for the horizontal transformations. It's going to get a little confused because I used h of x over here. So let me call this guy F, G, A, B, C, D, E, F, G, H, I. I'll call it I of x. And then that'll just show you guys moving the graph horizontally. So again, play around as much as you like, whatever helps you the most. So Desmos is so dynamic in that way. But I will change it back lest it cause confusion. I'm going to change it back to just the shift to the right by 3. And I'll save this and share it with you. So I hope that kind of makes you feel a little bit more confident, even with the skills you gained in Unit 1 on transformations. I hope it makes you feel that what we learned about moving graphs left, right, up, down applies to any type of function. So it doesn't just apply to absolute value graphs like we learned, or quadratics like we learned. It applies here to rationals. And in our next unit, it will apply to exponentials and logarithmic functions. So pretty cool knowledge you guys have about transformations. Really, really powerful. Now, the last thing I was going to say, and then we'll call it quits for this video, is how would you feel about the asymptotes, right? You can see I still have the asymptote showing for my base graph, but let's turn off the base graph asymptotes for just a second. And let's talk about the asymptotes for just one of the transforms graphs. So I'll just talk about the purple graph that I have. If we transform the blue graph to the purple graph, it did not move up or down at all. So would you agree the horizontal asymptote is still at y equals 0, right? There wasn't any change in the horizontal asymptote. So I'll just go ahead and throw in the horizontal asymptote in a familiar way. I've been graphing those in green. But then the vertical asymptote for the base graph was at x equals 0. So if we've shifted the graph to the right by 3, are you guys good if I say that the vertical asymptote must be at x equals 3? I'll put that in there as a dashed line. So if the function transforms, meaning it gets moved left or right or up or down, the asymptotes will also transform. And you guys are good on that because I know if I asked you specifically to find the vertical asymptote for the function I have highlighted, you know algebraically how to do so. I'm just kind of showing graphically that it is what we think it is. So the asymptotes shift around as well if the base graph shifts. So hopefully that helps a little bit. Let me know what you think about transformations. I hope you're starting to enjoy them.